Okay, here are your 5.1 notes. Now remember, before you get to an example, you can pause it, try it, and then play my answer, but I won't be doing a lot of pausing like in a live lecture for this. So first we need to start off with those definitions. We are moving on to the next key geometric shape, which are circles. We've covered all the different polygons, and now we need to talk about circles. So some vocabulary. A circle itself is the set of all points equidistant from a given point called the center. You might think that's a strange way to talk about a circle, but that set of all points being equidistant really is referring to and setting us up for the radius, because we know that from the center of that circle, the radius is equidistant all the way around. Now, a chord might be a new term, and a chord is a segment whose endpoints are on the circle. So for example, AB would be a chord. For example, DC would be a chord. Okay. I should have also mentioned we name circles by the center. So this is circle, that's the symbol P. That's how we know which circle we're talking about. Now a diameter is a term that you're familiar with. It's a chord, a special chord, which passes through the center of a circle. So for example, our chord diameter is DC. A radius, again, something that you're familiar with but maybe haven't thought about defining, is a segment whose endpoints are at the center and on the circle. So from the center out, from the center out. Okay, so for example, PB and PR, PC are all radii. Now a secant and a tangent are two new terms for circles, and they're going to be very important as we go through. A secant is a line which intersects a circle in exactly 2 points. So if I have circle Q there, a secant line cuts through like this. And remember our notations for a line. Or a secant line could cut through the center of the circle like that. Now a tangent line is a line which intersects or touches a circle in exactly 1 point. So the tangent lines look something like that. Well, let's give this another point out here. So for example, AB would be a tangent line. Or something like WD would be a tangent line. The point at which they intersect for a tangent line is called the point of tangency. And that's going to be an important point for us later. So those are some key terms. A couple of review terms we have to make sure we talk about. Remember, circumference is our distance around a circle, or it's our perimeter. We just give it a different name with circles. And we find perimeter for a circle or circumference as pi times d, where d is the diameter, or circumference is pi 2r, because we know that 2 times the radius is our diameter. Remember that our label on circumference is just units. Now, area is the covering of a space, and that is pi r squared. And remember, our label is units squared, always on area. We're going to be talking about exact answers a lot. And exact answers are so easy. Basically, with exact answers is you leave pi in the answer. Don't multiply by pi. And learning to handle pi is super slick because pi acts like a variable. So for example, if you have 3 pi plus 4 pi, you get 7 pi, which is way easier than multiplying by 3.14 blah, 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 plus 4 times 3.14 blah, 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 needing your calculator, not being able to do it in your head. Leave it as an exact answer. For example, if I have something like 5 pi divided by pi, this is also easier because pi divided by pi cancels, and my answer is 5. I don't have rounding errors. I don't need my calculator. Life is good. If, however, you need to use pi and multiply it out, be sure that you're using the pi key on your calculator. It looks something like that. It might be a second function. That's going to give you all of the digits of pi, and you're going to get a better answer with less rounding error. So let's do a little bit of review. If we are going to name the circle, that's simple. We find the center, and it is just circle H. If we want to name a chord, there are several chords here. A couple of chords would be chord AB, endpoints on. Chord DB would be another one. Or you could even do chord, well, we'll leave it just at that. 2 examples. Remember, a diameter is a special chord, and in this case, our diameter is DB because it goes through the center. A radius is from the center out. The only 2 radii we have in this picture are HB and HD. A secant line, remember a secant line is going to intersect in 2 places. And so our only line that does that is line AD. And a tangent line is only going to intersect in 1 place, and that is line EC. The point of tangency for that line is C. Now, what looks like maybe a complicated problem, but once again, if we work from the picture, it's not so bad. Find the length of QT. So I'm going to take my highlighter and highlight what we're looking for. I'm given that R to S is 4. I'm given that P to S is 16. That's the diameter. And I'm given that R to U is 22. And that's the other diameter. Well, basic working knowledge of a circle. Half the diameter is the radius. So R to T is 11. And from Q to S is 8. And I have overlapping segments there, so if I subtract out what's overlapping, if Q to S is 8, but R to S is 4, that means this little piece right here is 4. And if R to T is 11, but R to S is 4, then that means this little piece right here is 7. So if we use our parts to whole, QT is equal to QR plus RS plus ST. And if I drop in my values, making sure I don't have any overlap, I find out that the length of that is 15 units. Now these are classic kinds of problems that you maybe have seen We're going to change it up a little bit for number 2, but given the diameter is 16, what is the circumference? Well, if circumference is pi times diameter, our circumference is 16 pi units. That's your exact answer, and you can be done right there. If it asks for an approximation or you have to use this calculation later, the approximate answer is 50.3 units when you multiply by pi. Now this, number 2, given that the circumference is 24 pi, what is the radius? Initially that seems kind of scary, but if we write down what we know, that circumference equals pi times diameter, basically do a substitution. I know what my circumference is, 24 pi equals my formula for pi. Now I have an equation that only has one variable. I'm going to divide both sides by pi to get d by itself. Pi divided by pi cancels. Pi divided by pi cancels. My diameter is 24, which means my radius is 12 units. Had you multiplied 24 by pi and then rounded and taken 3.14 and divided, you would not have gotten a nice, even, exact answer like 12. Now, a few more definitions. Concentric circles are really cool. They're coplanar circles, means they live in the same plane with the same center. So this center right here, there's a radius, and from here to here is a radius. They have the same center. So that makes for some cool potential problems. An inscribed figure and a circumscribed figure really are just talking about it's English skills. Are we talking about the outside figure or the inside figure? Same difference. It's one geometric figure inside another one. The inscribed figure is telling you which one is inside. So it's a geometric figure inside another geometric figure with the inside figure's vertices on the outer figure. So we can have polygons inside of circles. We can have circles inscribed in squares. Just telling you which one is the inside picture. A circumscribed figure is basically telling you which one is the outside figure. A geometric figure drawn around another figure so that all the vertices of the inner figure are on the outer figure. So here we have a polygon circumscribed around a circle. Okay, so it's just letting you know which picture is inside and which picture is outside, which matters quite a bit. Cool theorem though, an inscribed quadrilateral theorem. If a quadrilateral, any four-sided figure, doesn't have to be a parallelogram, doesn't have to be a kite, any four-sided figure, if it's inscribed in a circle, then its opposite angles are supplementary. Very powerful. That means B plus D, it's always going to be equal to 180, and angle A plus angle C will always be equal to 180.